Okay, so in the last video we came to this conclusion that the electric field would be rho L A H over 2 epsilon 0 A squared plus A squared to the 3 halves A Z. That's the vector. And just in case we didn't see the last one, let's just go back and look what the question was. So we have a circular ring, so this is a circular ring, and carries uniform charge, so rho L, and it's placed in the xy plane. So we're just trying to figure out basically the charge at like a point right there. Okay, so that's what we're working with now. Let's go back to the second part of the problem. So what values of H gives the maximum value of E? So obviously if we want to find a maximum, we could take the derivative, right? So let's just take the derivative with respect to H. So we're just gonna do this. Take this. You know, I'm gonna copy it again just in case I want to save this for some reason. So copy. Okay, that's pretty good. So now we are going to take the derivative. Okay, so what do we get? So we're going to have dE dH is going to equal to, so first let's just take out the constants, right? Rho L A over 2 epsilon 0, and then that's going to be 2 over del H of H over A squared plus H squared to the 3 halves. Okay, so I guess we have to do some like derivative thing, which I haven't done in a long time. I guess the best way would be to do a quotient rule, which is the top times the derivative of the top times the bottom. So it's going to be 1 times the derivative of the top times the bottom, which is going to be A squared plus H squared to the 3 over 2. Minus the top times the derivative of the bottom, so that's going to be 3 over 2 times A squared plus H squared to the 1 half times 2H all over the bottom squared, so it's going to be A squared plus H squared to the 3 halves squared, so that's going to be to the 3. So now I guess I will just try to do some stuff and see what I could do. I definitely could take out to the 1 half. I could take out, I'm just in the mood for some reason to take out, I'll just take out one of them. So it's going to equal to A squared plus H squared times, I'll just write this in a different color. It's going to be A squared plus H squared to the 1 half, right? Now we got the 3 halves and the 2H, so that's going to become 3H, right? So minus 3, and that's going to be 3H squared actually. And since we're taking away 1 from this is going to be A squared plus H squared to the negative 1 half. I hope everything is right so far. And then divided by A plus H, A squared plus H squared to the, I'll just say times a squared plus h squared to the squared. So then I can obviously cancel this out, right? So then, well, so this is kind of, I guess this is kind of better. So remember, we're setting this equal to 0, so we're trying to find the relative extrema. So we've got 0 is equal to, and since like the denominator can't ever be 0, so we don't even care about it, so we just have a squared plus h squared to the 1/2 minus 3h squared times a squared plus h squared to the negative 1/2. Move that to the other side. We're going to have 3h squared times a squared plus h squared to the 1/2 negative is equal to a squared plus h squared to the 1/2 times both sides by a squared plus h squared to the 1/2. We're going to have 3h squared is equal to a squared plus h squared. We're so close now. We're going to have, we could just subtract the h squared down, so we have 2h squared is equal to a squared. H squared is equal to a squared over 2. So h is a height, so it's going to have to equal to a over the square root of 2, which is the same thing, which is fine. I'm going to just leave it at that. So that would be our answer to what values of h gives the maximum value of e. Well, technically we're not sure. Do I want to test it? No, obviously I don't, but I should. Obviously, what could I say? Damn, that's so messed up. I mean, I guess I'm making a video, so I should do it. So can I test with this? If I test with this green thing? Or... I mean, I don't see why not. Whatever, let me just test in here. So let me just put in, if I put a is equal to 0, if I put h is equal to 0, we get, so I put h is equal to 0, h is equal to 0, I get a squared to the 1/2. So let's just test this out first. So I'm just going to test this right here. So let's let h equal 0. Then we've got a minus, so that's going to equal to a. Alright, now this can't be that bad. So our real derivative do these constants matter? Whatever. I know this has got to be it. What else is it going to be, right? So that's what h is. Okay, so now let's just figure out what e would be, right? So let's say h is equal to a over square root of 2. So we put in h is equal to 0, we get 0. We put in h is equal to a, so let's just see. So let's see, e, what we have when h is equal to square root of a over 2, a over radical. So we're going to have, let's see, rho L over 2 E0 of a squared over square root of 2 over a squared plus a squared over 2 to the 3/2. So that's going to be a squared over square root of 2 times a squared. Alright, damn, this is too complicated. I don't know. I don't even know why it would matter. Anyway, that's my question for you. Why does it matter? If the total charge on the ring is Q, find E as A is approaching 0. If the total charge on the ring is Q, find... Okay, so again, let's copy this again. Copy. Paste that thing. And let's get the problem too, because I just want to really think about it. Copy. Paste. Okay. If the total charge on the ring is Q, find E as A is approaching to 0. Well, obviously we know that so we know, let's say that Q, total charge is going to equal, we know it's going to be the charge density, or length, since it's a length, times the length, right, which is going to be 2 pi times A, right? Okay, so we want to find as A approaches 0. So we want to find, so dq I mean, just going by the formula, I'm assuming that it's going to be 0, just because you know, E. Let's see. So we could also say, okay, so we could say that E is equal to 2 pi over 2 pi, right, times rho L AH over 2 epsilon naught times A squared plus H squared to the 3/2, right? Because I multiply the top and bottom by something. So now what I'm going to say, so I'm going to say that this is the charge, so I'm going to say that then E is going to be equal to, so this right here, so this right here is Q, or 2 pi a times rho L, so that's Q. So I got QH over 4 pi epsilon 0 times a squared plus h squared to the 3 over 2. So now if I want to find, so I want to find so E, the limit as a approaches to 0, it's going to equal to QH over 4 pi epsilon naught. A is going to be 0, so it's going to be h squared to the 3 over 2, so it's just going to be h cubed, which equals to Q over 4 pi E0 h squared. So what that is basically saying is that this is it becomes a point, right? So we just would have something like this. So this is just going to be our thing right here, and this is our h, and then here's where we're testing it, right? So that makes sense, right? Because it's just going to be the charge times 4 pi epsilon 0 over r squared, but r is h. So that's it. Hope this makes sense.